Okay, so you can see right here on the screen, I am thinking to redo all of the lesson that I have done, so that it will be kind of a revision for me, and also a compiled video of all of those tutorials. I have already made some notes on related to those video. I will be opening one by one, and then these are basically the summarized version of each of the video. Like for example, this is the first video. Yep, this is it. And in this video what I did is let me see. So we did id command who I am plus group, and then who am I just username, and these. So these are like cheat sheet, and the same exact pattern will be followed for all of these videos. I don't know for how long this video will be, because I just start recording right now. So I'm just gonna start it right now, and let's see what gonna happen. Okay, so we have this Linux machine, try hack me, and because I don't know why this virtual machine is not working for me, and I'm too lazy to check it out why it's not opening. So we have the Linux and we have this. I'm just trying to make it like this so we can see both of these at the same time. Let me make it like this. 1 second. Let me drag it here a bit more. Yep, better now. Now let me just open the terminal and start following the cheat sheet. First of all, I need to make it big so you will be able to see it more clearly. So first of all, we have the id command. Let's just run this. Okay, so id command basically give us the id of the currently user we are logged in into. The 0 id is for the root user. Whenever you see the 0 id like right here, it just means you are a root user. And from 1 to 999, or I guess 1000 it just these are the id for service account and a bunch more account. Okay, I might be able to see it over here. I hope so. Okay, it's not there. Yeah, it's there. Yeah, it's there. So from 1 to 999 is the service related account, and from the 1000 and so on, these are the regular user, the ids. These are the ids that like kind of regular users id. Okay, and this is the group id. This is also root, so that's why it's 0. Okay, and let's just run now. Who am I? So who am I? Yep, this will just print out the name of the user that we are logged into. We can see a bit more detail over here. Okay, so when you type the id command, you might be able to see some other group and not just the root. Like for example this one. So this is one user. Can we make it big? Yep. So this is one user, this is another, these are some other user. And if you type the id command and see the sudo, this means you are able to run commands as root, and you don't actually need any password. And if you belong to a shadow group, it just means you can read the etc/shadow file. What this file is, it just kind of store the password hashes. In simple terms, it's I guess more like gibberish kind of password, but we can actually use this to log in and log in into accounts and services. And then we have the Docker. Okay, and we also have the ADM. If you belong to this group, you can read some log that might contain credential. So I'm just gonna, okay, so we are not from this ADM group, but wait, we are a root user, so we can actually go to cd var log. Let me type ls. Okay, we can there are some logs. Let's see this one. I will just type cat user log. Let's see what we gonna get. I don't know why it's a bit slow, but okay, till we get the response we will see what these are. This is some related to printer related, this is for scanning, and video related. So if you see, when you type id command and see either of these three groups, you have like a bit higher level privileges. Okay, we let's just see what is in this. SSH host key fingerprint. I don't know, really know what do we use this for, but okay. And I don't know if we are able to see or if there is something really important in this. Okay, I don't see anything. There is one file that we can use to kind of syslog. Is that syslog, I guess? How about we do the recursive proc? Come on, it's not working. I think I need to refresh this. So this one contains some system related log, this contains user, this contains kernel logs, this contains authorization log. So I'm just gonna use this command. This is the grep. This will just kind of filter out the this sort of string in this or.log. So grep I pass and this in this or.log file. Okay, there is like not some really good stuff. Let's just type the grep again. Okay, I think having this Linux on the single screen is performing better. I don't know what is the problem, but yes, kind of causing this. So I will move these nodes to the second screen and then type this command grep. So it's the same command but with syslog file. Okay, and let's make it password. Still we don't see anything. Let's just move on to the next step, which is who am I sudo, what sudo commands we can run. I wanna check this one. Did it get us response? Let's see what else we can do. Okay, we just already done this. So this tell us what sudo command we can run. This just give us the user related information. This tell us the user ID and also other group that we belongs to and their IDs. And when you type the ID command, you will be able to see, you might be able to see other group. And as I told you, these three are the really important ones. Okay, this one as well, but these three are really good. You can read some logs that might contain some credential. The shadow, you can steal the password hashes, and sudo, it means you can run any command with sudo permission. Okay, it just give us the response. Okay, user root may run the following command on this Linux. So we are root user and we can kind of use all of the command. Okay, now let's move to the second part, enumerating other user. So we got this passwd file which contain the full list of all of the user, including the regular user, the services account, the network account, everything. Okay, so it's right here in this etc directory, etc password. Yep. So we're gonna move to like this to home directory and then etc and then ls. Let me do ls and let's see if I can find the password. Yeah, it's right there. So what we can do is type the get and passwd and boom, we got a list that contains all of the user. Let's do it like this. So we have the root, this is the username, and then this is the password hash. Let me open this. If you just tap this, you will only get the username. Or let me try this, and after that I will explain the re-explain, because I have explained already these. So copy paste. Let's okay, let's remove the m. Bro, come on, I don't know why it's not working, but okay, we can already see the username as well. So okay, this first thing, just show the user account, the username, and then this x you see right here, these are actually the hash password. So back in the days, it used to show the real password over here instead of the x, and now as as time passed, they just, for security reason, they use the x to hide, to not show the hash password. And then what is the 00? I just kind of forget this. Okay, we got this. Yep. So this is the user ID. Okay, this is the user ID, this is the group ID. All right, since we are a root user, so we belongs to root group. Okay, so the group ID is also 0 and the user ID is 0 as well. And then this is some, okay, this right here, yeah, the last thing we see over here, this is the shell. we have different type of shell. I think I have not like discussed or made any video about the different kind of shell, but we have like different shell, ZSH, bash shell, and a bunch of some more. And this is the user home directory, okay, kind of, I guess. Yep. And this is the command you see over here. This is the full name. As it says over here, command is basically the full name or description of the user. We already know this. Now let's see what else do we need to do. We already done this as well. Yep, we are good. Now we can just simply move to the third node part. Okay, this is some related to the finding out the terminal history. I'm gonna just type clear over here and then type the history command. So what history gonna do is current shell history. So this is the shell that we just opened, and it just showed the current history of this specific shell. If I open this and type history, you can see right here we only see the command history that we just run. This is another shell and this is another. So this history command just show the previous command only for specific shell. And if I close this and open another, these command will be like kind of vanished. Let's go here again, and so these are temporary. When you close this, it will be vanish, and we actually have another file where all of these command, including a different terminal, not just a specific terminal. Like for example, if I run this command in this terminal and open another terminal, let me actually do this and type some gibberish command. Okay, so we have actually in the home directory we have a history file. So it's like the format of that is the hyphen history and the bash the shell name. So if you have a bash shell, you will see like this. If you have a ZSH shell, you will see like this. So as you saw earlier, we have the ZSH shell. So we will be looking the content of this. Let me actually cd this and type ls. Okay, I need to type ls hyphen la. So where is the file? This is it. Okay, you can see right here. I'm just gonna copy this, type cat and this. No, I think I did something wrong. Let me copy this and paste it again. Bro, what? Oh, we have the bash shell. Sorry, bash. I don't know what's wrong with this machine, but it does the work. I have tried this on my virtual machine. Right now it's not opening, otherwise I would have shown you that it works. Okay, I think we might have the screenshot of that, not sure, but okay, we don't have. So let's just move on. So it's like finding specific command or credential in a current terminal history. Type the history that just show the current commands history in the current shell, and then we do the grep to see if there is something like related to password or SSH or some other key. And this is let me copy this. This is filtering out the word password in this. So we don't have right now any word in this file, so it's giving us nothing. Then we can next we have check which shell you are in. Echo shell. Okay, echo shell. I think it's like this. Yep, we have the ZSH shell. I think this is wrong file, so that's why we are not seeing any history. Let me do actually ZSH like this. Let me also remove this. Bro, come on. I don't know why we are not getting any history, but I promise it works. So when you type the echo shell, this is something related to the paths which we will be covering in the coming parts. And this is something new. If you want to check the shell history of other user, you will just kind of type the cat command, which is normal, and then home, and then the specific username. Like if I type like when we type the cat etc/etc/pwswd, give us a list of user, so we can get the any user id, username actually, and then do the cat/home/the username and then we were actually able to also see the shell type, so we can just type bash or zsh or any other. And if this will only work, the reading the history of another user will only work if we have the elevated shell. Elevated just simple term mean root access or in Windows administrator permission. Okay, and then this just kind of show the, okay, this is the same thing as the hidden file in the root, so the same thing. Now we can actually move to the another part, I guess. So quickly overviewing this is the thing that I just show you about enumerating the history of other users. You see, when you this is the example, like there is another, for example, there is another user called Alice or Bob. We have, and assuming we have the elevated access, we type this and we'll be able to get their history. You likely won't have the permission to read other user history file unless you have already escalated or found a misconfiguration. Okay, so when reviewing history, hunt for these pattern like SSH, password, or MySQL, or like something like this, or configuration file. Now we can just simply move to, so far we have done the id command, who am I, and then the who else exists. This we did this and we tried this, but there were no history, or I don't know, there might be something wrong with the machine, but it works. And now we'll be moving to another part where we will be talking about the host name. Let's just go. So we are here now, and okay, let me make it clear. Yeah, let's go and read this first of all. So we have the host name command, which just gives us the machine's name. And in one of the videos that we talked, when you type the host name, it just kind of give idea of what the machine might be about. Like for example, when you type the host name, it might give you the output like production server, MySQL server, or something like this. So from that we can know that this is for production or some other, so I think we will discuss this just in a moment. So now what command we have here is, first of all, we have the host. Let me type the host name. Host name or the machine name is Kali. Okay, and then to find out the operating system version and the distro name, there is a file in etc which is os-release. So I'm just gonna type etc os release. Perfect. So this is the version id. Let me open this and go here. Yeah, that's what I was talking about. When you type the host name, you might be able to see webprod01, meaning it's a production web server, or nyc-web01, a web server, or like file server. Okay, so if there are web server, we might look for web app vulnerability, and we can look for some misconfiguration or weakness. So we also have the uname-a. I will just type this. After this we type this already, and you can see the name. This is the operating system name, the distro name actually. Okay, distro name, yep. And this is the version. So this is the distro name and this is the version, and we can actually use this later to, like, you can see the distro name and the kernel version. Once we have that information, we can just kind of go to any of the exploit databases like exploit db or other website and search specifically for the operating system exploit. Okay, and we also have the uname-a. It's uname-a. So what this is, this is the host name, this is the kernel version. Okay, yep. So this is the host name, this is the kernel version, this one specifically. And then we have this AMD64. They just give us information about the architecture, machine architecture. Yep, we'll actually be covering the architecture in the coming part, right? And now what else do we need to type is we got these, we covered these, we are here now. Next we will be going and finding out processes, full kernel information, clean kernel version. Okay, uname hyphen r, this is the kernel version. Yep. So we got the distro name, distribution name, and also the kernel. We can just simply go copy that and search for the exploit. There might be some exploit for that, maybe. And to just get the information about the architecture, we're gonna type the uname hyphen m. Perfect. So this is the AMD one. We actually also have some other architecture type which we'll be covering in a moment. And this is one command that does all of these things. Okay, now I think we need to move to the another part, which is Unix, BSD, Linux. Let me make it big so we will be able to see it more clearly. Also, we already done these, the uname, this is kernel version, we already done this. This one is specifically about the different between Unix, BSD, and Linux. So in simple term, it's Unix is like the very first Linux. I will say it's actually not Linux, but to make it simple, it's the very first. This, let me tell you, from this you will be able to get this. So Unix was created on this, and it was expensive, kind of very expensive, and they were using only for themselves and were selling to other very high prices. This basically the functionality, the basic functionality or the main functionality of this was to you that multiple user will be able using because of this multiple user will be able to use a single computer device it simultaneously. Okay, and then they got the BSD, and then we got the Linux. So it's like kind of theory, it's not like very important. Okay, I'm gonna skip this and move to this Linux distro. So as I said earlier, when we get the distribution name, we just give this, and also the kernel version. We can search for exploit, like for example this one, and there are some other commands as well. I think I need to, the main point over here is that for example let's say there are different distribution and that uses the same kernel, and that kernel might have some vulnerability. So for example, the distribution one, let's just take the Ubuntu example, and then we have the distribution to let's just take that as Kali. So both using the same kernel. Okay, so what Kali did is they found out the vulnerability in the kernel, they fix that, and boom, nobody can exploit that. And let's say if somebody find out that exploit, that kernel exploit, and tried it on the Ubuntu, it will actually work. But if they try the same thing, the same exploit on the Kali, it won't work, because they just fix that. Both are managed independently, they are totally different distribution. So this is the main thing. The same kernel version number can be used by multiple distributions simultaneously, but each distro applies its own patches on top of that. So that's the main point. Okay, now I can just move to the next one. This is related to the architecture, totally theory, but it is very important to understand, because when you are compiling exploit, you actually need to know the architecture type of the system. Only after that you will actually be able to successfully compile and execute the exploit on the target device. So we already typed this uname hyphen m command, we got the architecture. Let me actually type again, uname hyphen m. This is the architecture type. And if I go over here again, see, we just got this, and these are the architecture tab. The modern Intel or AMD chips uses mostly the desktop server and most Linux, and there are 64-bit, as you can see right here. And if you just see this x86, it just means the same thing, but for older systems. You can see right here this this is the older one, and this is for the modern. Okay, and then we also have different chips as well, these that uses these architecture, the ARM. Mostly they are used by the Apple, because the main thing about the ARM chips are they are battery friendly. What I mean by that is they kind of use these chips to uh, make the battery life more, like increase the battery life. They are also used in Android. So if you see somewhere the ARM64, just mean this, and if you see this ARM V71, it just mean this is a 32-bit ARM architecture type. Okay, so this right here you see Apple uses these M1 M2 specifically, and most smartphone uses ARM. So if there is some exploit and you compile that with this x86 architecture type, it won't run on these devices, even this or this, because they are totally different architecture. This one will only work on these one, okay, and this one will only work on these one. So I hope you get the idea. And then this is the compiling. What is compiling is basically like when you type some code, some exploit in human readable language, the system does not understand that. It only understands zeros and one, and to convert these human readable language into machine language, we use compiler, simple as that. Okay, so the total flow will be like we get the operating system and kernel information by these, then we search for some exploit. We like for let's assume we got some exploit, but after that is we'll be coming we'll actually be also looking for the architecture type. We need to make sure the architecture type matches with the device and the exploit, and only then we will use the compiler and compile it, okay, using the same architecture type. So that's that, and now let's just move to the another part. I think we just did this one, covered this one already, the username, the kernel, the architecture type. I am just okay, this one is important. When you type uname -m, you get something like this. Let me actually type again uname -a. You see right here we got this result, and this is very similar to this one. Let's understand what this is. This is the operating system, this is the host name, okay, and this is the version number, okay, and this is the architecture type. So what's important over here is that these you see right here, when you install a software, they just do some updates, and you have to also install the updated software, and they just kind of changes their version number. So for Linux specifically, when we say like this first thing changes only when there is like some very big or major changes, okay, and then this is like minor changes, and then like for example there is some bugs or vulnerability, and that specific operating system, they just kind of fix that and type this. If there is zero, just mean they did not fix or they did not find any vulnerability. And then this 21 just mean this Debian applied their own patches 21 time. I'm not sure what this mean, but okay, yeah, I think there is nothing much in this as well. But one more important thing is that you need to match the kernel version with the distribution to find out exploit, okay. So like we have this exploit, the dirty cow. This will only work on Linux kernel below this version, and then we have, if you use this exploit on these version, it won't work, okay. Now I can just simply go to this one, running processes. Actually, let me go over here and type the PUAUX, clear PSAUX. Okay, we got a bunch of stuff. Let me move to the very top, yep, and go over here. So what this is, this just kind of list all of the processes from all of the user with full detail. So these specific these are the processes running with the user root. This is the username, this is the process id, this is the system usage, and these are the exact thing that the process is trying to run or doing. There is one important thing, when you see this, it just mean these are kernel thread, and I think I need to go over here and tell you this. Before that, you can see when you type this, you will find out the root, only the root processes. And like for example, let me go here. Yeah, so you see right here, these are some processes run as root. We'll see if we can somehow modify these binary or no. If we can, it will be so good, and go in this, simply change this or put our own thing here, and it will be executed as root. Yeah, so what I was telling you, these are the kernel thread, they just kind of don't execute. I just forget these, and it's not here. But the thing is, these, what we need to focus is, again, we need to find out processes. Like for example, this specific process, this is the id of that, is executed using this specific, uh, it's running this thing, and it's a foreground process. Okay, so we have the background and the foreground process. There was a specific name for a background processes, I just forget it. But the thing is, this command section you see right here, the full command including all the argument to start this process. This is, yep, to tell you more in detail the specific section, we need to come over here. And like for example, there is a server python script or something, and you want to start that. What you will do is use the python and the file name, and then it's something related to the database, and this is the specific ip, like connecting to the database, I guess. And you will just connect to this, you will use the ip, like the username and also the credential in the terminal. So when you press enter, it will be executed. Once this executed, you can actually, when you type the psaux, you will be able to see that here actually. Okay, so if we find out some credential, we can use to log in by ourselves as well. Yep, this is the background process, we call it daemon. They don't have any terminal. Daemon, okay, we call it daemon. So we use the x to see the background or the daemon processes as well. Without the x, we will not see the daemons or the background processes. And now the first step, what this is, every running process automatically gets its own directory inside proc and the process id. It's like a virtual file system. When the process stop, it just vanishes. The simple example, I guess, would be the ram. Yeah, it's right here. Say it lives entirely in ram and is created by the kernel in real time. So let's move to the /proc. Yeah, these are all of the processes right now running. Okay, and if we just kind of move to this one, cd 859, some random process, let's go and start this one. So why it's not okay? So we did type cd proc and the, let's do add 43. Yep, we are in that now, and we can see there is one file that show the exact command that just started this specific process. If we type the cat and the cmdline, perfect, this is the same, this is the exact command that started this process at 43. Exact startup command for this process id. And environment, let's see what this is, contain some credential. Oh, environment variable, okay. And this is who owns it, what state is it's in. I'm just gonna do, where is that file? Here it's so lsenv environment variable. No, I think I should have used the en. Okay, we got something, but I think there is no any credentials. So you will target some processes like MySQL or Apache or something like that, and then come to this proc and its process ID and run the cmdline, you will be able to see what command were used to run the process, and we will then check the environment variable file of that. Okay, and then let's see what else do we need to also cover. Yeah, we just did this. Yeah, so this is the same thing, but we are filtering out, like finding out only the MySQL processes that might contain some words related to the MySQL or Python or Java. Okay, so this is the goal, like this video or this not focusing on running processes, everything currently executing on the machine, and the goal is simple: find out the processes running as root, and check for hijack opportunities or some credential passed as command line argument. Okay, now we can go to the environment variables. Let's go over here and let me clear it and type the env. So we got a bunch of environment variables, you can see right here. So what these are is, I need to go here. So these are like named key value, they have a name and then they have a value, and in the value we sometimes store some program path or like some credential, like for example I type api equal to and my actual api. Okay, so later whenever somewhere I need to use in some program, I need to use the api, instead of remembering my actual api, I will just use the environment variable api. It will just automatically grab the actual api from there, right? You actually saw that as well. So when you type the language, like finding out the language, or let's say the what should we go with, let's say a login name. Okay, so when you you need login name somewhere, just take example. Okay, and you don't know the login name, but you know that you need the login name, we and you already know that we already made up environment variable with the name login name, and when you use that you can actually get the same value, the actual value. So that's like that. And the main thing is sometimes the variable contains some password api, like for example db database hyphen password equal to the password or credential. Right, this is the same stuff that I just told you. So it's now like filtering out for password key secret token, there might be some token api that I it just mean that let's actually copy this. I'm sure there might not be any password. See, we did not get anything because there is nothing in the variable that contains the password, so that's why. Another really important thing is when we have the local variable and then we have the like kind of global variable. Global variable just mean that when you create that variable, it will only work in the terminal you created it. Like for example, I type what was the command? Oh, okay, it's just variable name. My name equal to xyz. So now when I type the dollar sign and type the my name here, it will just how do you get the, okay, you will have to, I will have to use the echo and this dollar sign and then the variable that we created. So now if I created another terminal and use the same command like this, let me create like this. You can see we did not get anything because this is a local variable. To make this variable like global, which means that not only it will show here but here and every single terminal. Like for example, if I type the env, these are the kind of global variable, the path, the actually the path, the login name, and same here it will list the same thing. Oh, so to make it global or usable by every terminal, we will actually use the word export, the term export. No, wait, the when you use the export, it will the current terminal and its like child process, the process that you run from that terminal, it will be able to use that variable. Okay, not from another terminal. Very important. But to make it a permanent or global, you will actually need to store that in this specific file depending on the shell type. If you have a bash shell, you will put that there, and if you have a zsh shell you will put it there, okay, and it's in the root directory. I hope it makes sense, and I think there is nothing more. Yep, wait, we have actually path hijacking of the variable. Let me actually read it. Path is the most important environment variable for previous. It's colon separated list of directory that Linux searches in order when you type. So when you type, for example, ls, it just does not magically appear unless the content of the directory. It is actually a program and a file that is stored on the Linux. Okay, and what happens is that when you type ls, it just first of all check in this directory, this one. Okay, if not found, it then go here. This was the s pin and this is the without s, and if still it does not found that, it go here and then go here. So normally the ls command or program is here. When you type the echo dollar path, this is the path variable from which we can know that where it find out the programs. So the thing is, if let's say we are able to somehow write in this specific directory, okay, or here or here, so what we can do is make our malicious program and we will name it ls. So next time when we type the ls, it just go here, it will not find it, it will then go here as usually. What happens is that our program, malicious program, will be here, and once it go here, it will execute our malicious ls program. And the thing about this is, whenever it just find any matching command, matching name, or like for example I type the ls and it find the ls here, does not matter if it's a real ls program or no, it will execute that, and it will just stop the searching then, because it found out already the ls program and executed that. Path hijacking will be covered in full detail in a full detail video. Yep, that's correct. So far we have talked about this one, these bunch of stuff, not this one. I will be telling you this in a bit. I can just simply move to the services. I think in this one we'll talk about the services system md enumeration. So we have covered that system md is like a network manager, and the system ctl is like the person who talks to the manager, who like kind of this is like the boss, okay, the system md, and this is like the its employee kind of. Yeah, system md is the building manager. The when the hotel opens, the manager automatically start the ac, elevator, kitchen, yep, without needing anyone or manual doing it. So in Linux it just means that system md is something that manages all of the processes when you just kind of log into or opens your Linux machine. And system ctl is the guy who will talk to the system md or the building manager. So if I go down over here, yep, this is the guy who will ask question from this guy or make queries. System ctl list unit. Here we have the breakdown of this. This will only actually, when we type this command, this will list all the services, only the services, and if we add also the state, it will only find out the failed services, failed for whatever reason. Okay, so I'm just gonna copy this, paste it here. Yeah, you can see we got a bunch of processes. Some are running, some are not running, some are dead. Bro, what is happening? I need to refresh this. Yup, much better. So these are the processes you can see right here, and we can actually to see only the failed process. We can do something like this to also specify the state. Is it failed or like? See, we have 0 failed services. So we might hunt for the high value. These are the kind of high value process services, Apache and DSSH or the MySQL. And if there is some misconfiguration or like some they are running some old version stuff, we can actually do some find out some exploit for that. So quickly I'm just gonna do it because I'm too tired right now. File enumeration. In this video what we did is we tried to find out specific or writable file that normally we should not be able to write to. So we use the find command, and we try to find out files in the root directory. Okay, this, and then we actually also try to find out files that have the SUID binary. So yep, this just mean whatever the SUID has the has the SUID, it will run as root no matter from which user to execute that or run that file. And then we in etc we okay, yep, we use the grep to filter out, or to like, yep, use the grep to filter out, and the -ri mean recursively to go inside folder and inside their file, every single folder and file, and find out the string password in etc directory. And this just mean remove all of the error and this stuff. And one more thing is that we use the I specifically to make it cans insensitive. Does not matter if there is like something written in upper letter or lower letter. And this is hunting for the SSH keys and root on writable file, like the file that is owned by root, but we as a normal user uh, can write to that. So it will find out those files, and it will find the backup files. Okay, now let's go here to the software. It just kind of, these are like software or tools manager, dpkg, and we actually have one more, the rpm. Most of the time we'll be dealing with this. Personally, I have not come across with this one. So when you type this dpkg-l full list of the installed software, right, and once we get that, not only we'll see their name but version, architecture. So once we type this and find out some software that might be older and not updated, we can go to exploit database or other website to find the exploit for that and exploit that. And for network and port enumeration, the netstat is the best one I have used so far. The SS, I don't know, never heard about this. So when you type the A and B, it will list all of the connection, including listening established, right? And the network interfaces, the IPADDR will show this network interfaces like ETH01, ETH1, and the wireless interfaces. Okay, now the most common one is this one. You type this and you all see all of the interfaces. This just tell us if there is any other interface that is connected to some other network that might be act as our pivot point, right? And this IP link will show the interface that is it up or down. I mean, this one will also show it. And then we have the network routes. After mapping open ports, the next step is the machine internal assign point. In very simple terms, like assign board, like to reach this network use this interface, and to reach that interface use that interface, to reach that network use that interface. Okay, and cron job is the schedule task. Simply just we'll try to find out the schedule task specifically run by the root user, and we'll try to see if we can write to that specific thing or executable file or modify that. If yes, we can put our own malicious stuff. So I'm just gonna end this right here. I will see you in the next video, which will be about the automated enumeration of Linux. See you soon.